Hi, my name is Evan Korean, and I'm a part of FRC Team 8576 Golden Warrior Robotics. So today we'll be learning about how to program sensors and autonomous, and this is a part of our FTC video tutorial series. So, what are sensors? Sensors are devices that can read outside data and allow you to communicate, and it communicates with the robot. And you can use these to make your code more advanced and do a more things like you can make it follow paths for order. You can make it detect objects with computer vision, and you can do a lot more. So this is the web touch sensor. This sensor is like a button which can detect how many newtons of force is being applied to it, but it's rarely used because people don't find it necessary due to the built-in features of motors and encoders, which we'll cover soon. So then we have color sensors. There's multiple color sensors sold by companies like Rev and Burslens. So these can detect color and it can be useful in seasons where in autonomous you don't need to be precise to pick up game elements, and there's alliance specific game piece colored specific pieces like for example the bricks from Into the Deep season, which were blue and red, and so you can detect the color using that. Next, we have computer vision, uh, which is a basically camera that can identify things. So it uses a AI trained system based on image models to find game pieces, or you can use the cameras to scan April tags on the field, which are like QR code, and they can tell you the distance or angle of your robot. But they're hard to use for rookie team and require a more advanced programming knowledge and a bit of geometry and trigonometry math to use. So now we have encoders. Encoders are sensors that are either built into the motor or they are sometimes separate, and they can track the rotations of the motor. And how they track it is every single revolution. There's a certain amount of encoder ticks, which is how many pulses it moves. Like, but for example, if a motor rotates once, it can have 1,000 motor ticks, and you can use this to find a distance the motors went. There's two types of encoders. There's an absolute encoder, which the position it will return to the robot will always be the same. Even if you turn off the encoder and turn it on again, it will return the same exact position. Or the relative encoders, which resets back to zero every time you restart the robot. To find the encoder ticks or motor that's built in, you can go to the website. Like for example, if you go to the Go Builder website and look at a yellow jacket motor, you can see the thing that says encoder resolution, which can tell you the how many revolutions ticks per revolution it has. Now we have the final and most advanced sensor that most people use, which is odometry. It's like an encoder, but it's on its own separate spring-loaded wheel or gravity-loaded. Because if your wheel slip, like if for example it goes accidentally off of the floor, your encoder is spinning in the air and the robot's not moving, which throws off the distance. But with springs, you can make sure it always has contact with the floor, so it'll track it more consistently. And you can use this for high-level autonomous paths, but you'll to use these you'll need to use Android Studio and sometimes custom libraries depending on how you do it. So some uncommon sensors we have is optical odometry, which is like an odometry sensor, but instead it shoots a laser out, so it's just a laser. It's the red board right there. Then we have distance sensors, which turn it's an ultrasonic distance sensor, which returns distance. Then we have limit switches, which can be useful, but when it's clicked and the metal prong right there in the middle of the screen you see is like pressed down, it will return an electrical signal. And then we have an IMU slash gyroscope. I didn't talk about this because there's one built into the control hub for you, but it can track acceleration, the rotational acceleration, and it can tell you how many degrees your robot's moved. And it's very useful for autonomous. So now we'll start coding a simple autonomous program. So we'll be going through a basic autonomous program that moves the robot for a set amount of time and speed. And I will not be explaining the program and the setup, and because we covered that in the programming video in our series. So go watch that if you haven't already. So to start, you declare and initialize your motors again, but this time we're going to do something else. We're going to create a elapsed time object, which is a timer, and we need this to track the amount of time the motor is going to move. And we do not need a loop. We just have a wait for start block because this is autonomous and it only runs once. Let's make sure to open up the file which is found on our GitHub page, and let's skip down to where we declare functions, which are like blocks of code, custom blocks of code that we can have. So over here, we create a function. It's called move forward, and there's two parameters. We input a speed and the amount of seconds we want the motor to move. So to use this, first we set the speed of the motor to the speed that we inputted, and make sure when you do this to do one time dot reset to reset the timer, and it'll immediately start tracking time. Then we'll have a while loop, which while the autonomous is still on and the seconds that it's been running since we just reset the timer is less than the amount of time we specified, it will continue doing the thing. There's nothing in there, so it'll just continue doing what it already was. Then after we're done, we'll stop the after it breaks out of the while loop because the time is already done. It will set the motor power to 0 and it will move on and it'll stop everything. So let's go back to the wait for start. So after the wait for start block, we can see this is how you use a function because it's in the same exact class. So we can do move forward and we input our parameters, and then we can do the sleep function, which we learned about in blocks and also in the programming tutorial, which can sleep for a amount of milliseconds because we don't want it to go immediately to the next one because we might want it to stop a while. Then once we're done moving, we must do request alt mode stop. So it'll request the autonomous mode is done because we don't need the autonomous mode to keep on going forever because we want it to end before 30 seconds. So now we'll be going more on how to use encoders. So to find the amount of ticks the encoder has is you go to the manufacturer's website and you look for the encoder revolution or the ticks per revolution, and I'll tell you how many ticks on that encoder makes one full rotation on that motor. And soon we'll see how we can use this to find distance. So if we can use this to find the distance the robot moves, because if we find the circumference of the wheel the motor is attached to, and we can use that circumference and multiply the amount of ticks, multiply that circumference by the amount of ticks the robot's already moved over the amount of ticks per revolution, and it'll tell us how much of one full wheel revolution it's moved, and using that it'll tell us how many distance we've moved. So now let's move on to how do we use this in code. So we can declare a motor object, and next create a double variable to store the amount of ticks per revolution or how many ticks, and we set a new target, which is we're going to calculate the new target position. Assuming we already initialized the motors and stuff, this is a bit older format, so it uses something called a public void loop, but all we have to worry about is if this was the while op mode is active loop. So what we have right here is in the loop method, we have pressing the A button on the gamepad returns this function that we'll make that and we input 2, and then we add telemetry, and if we do X, we'll initiate the tracker function that I'll show you how to make. So what a tracker position does, it sets the motor encoder position right there using the dot set target position, which is in ticks, and we set it to 0 so it will go back, and we set the motor power, and we set the mode to run to position so it will run at that speed to the position. And then we have the public encoder method, which it moves the motor a part of the turn. So we use a total amount of ticks and how much we want it to turn. We set that at the new target and we want to that position. But also, you don't need to do the turnage. You can input ticks, how many ticks you want to move, or you can multiply the distance by, or you can figure out how I told you earlier, the amount of distance the encoder ticks can give you. Like using the circumference of the wheel, you can find out the how much distance is moving, and using that, you can tell the robot to move a certain amount of distance. Or you can do the same thing with angle, but then if it's an arm mechanism that moves up and down. Then we set the power speed to low so it'll move to the target, and that's the end of the code. Thank you for watching this video to the end, and in the description we'll have some resources to learn how to use some of these sensors on autonomous, like the book Learn Java for FTC, which is a really good ebook and it's free online, and we will link down learnroadrunner.com, which will tell you how to use a Adometry for path following and make sure to use version 1.0x of Roadrunner, and we'll link down some YouTube videos that might help. Thank you for watching.